All right, let's look at B tree indexing levels. In SQL Server, there's three basic levels. The first one is the root. Second one is the intermediate level. And then, of course, the third is the leaf level. And you can see the image on the right, which is, of course, from Microsoft. And there are differences on the, by the way, the leaf level between clustered and non-clustered indexes, of course. So we'll cover that later. But one of the keys to understanding about the indexing structure is that the leaf level is where you are writing your queries for. And what I mean by that, that is where the data are at, right? That's where you're getting and retrieving the data. So knowing that from the beginning, we can think about the columns that would be most appropriate for this level of filtering. Because the other level, I would always like to think of the root level as being like the book itself, right? I want to find a passage in Harry Potter. The intermediate level is like the table of contents. Of course, this assumes that I know what chapter that passage is in, right? I mean, what happens if I don't? It's going to be a lot of work. And then, of course, the leaf is going to be the actual sentences, paragraphs, words, etc., right? That's where I'm going to actually have to go out and get those. So my search from the beginning is looking for the rows of data, and then I'm going to go inverse and go upward and think about, okay, so if I'm going to want, let's say hypothetically in a search, I want to get all mortgage loan balances in the state of Kentucky that are greater than $100,000, what do you think are going to be at least one and maybe two columns that I would be looking at indexing? Okay. Now, knowing that about, let's say, the rows of the leaf level rows of data that we're fundamentally trying to retrieve, in a generic case where you could have any combination of XML, would you index an XML column? Let's go back to the example of the loan balances over $100,000 in the state of Kentucky. Would you consider indexing loan balances, or would you consider indexing Kentucky? By the way, that's a good example of one that it depends for me, because I might not consider indexing loan balances if indexing Kentucky results in a data set that may be smaller. And I don't, for the record, happen to know, but let's suppose that my data set only has 1,000 records in Kentucky. And of those, I mean, I look at it this way, well, how expensive would it be to read 1,000 records if my filter's on Kentucky, and SQL Server can get to that assumption very quickly? Now it just has to go through 1,000 records. And even then, it may not have to go through all of those, because depending on the order, right? That's a good example of one. I remember there have been several situations in which, with mortgage-backed securities, we were looking at indexing loan balances. But it definitely was appropriate in certain situations. And depending on how you structure the data, especially if you scale it or you're keeping historic records, it might actually be something useful, especially in OLAP environments. Likewise, where do you think all of the writes of transactions are occurring? On which level? Right, the leaf level, right? So consider that. An OLTP environment, I always say, needs much fewer indexes than an OLAP environment, because fundamentally, they're both looking at the same level. So everything we're building in terms of indexing is to get us to that leaf level. Likewise, where do you think the deletes, the updates, and the inserts are occurring, right? And you can also see why, when you look at this structure, where do you think all of the fragmentation is happening, and why do you think that's going to affect everything upward, right? So that's one of the reasons why we rebuild indexes. That's one of the reasons why we have to be careful about indexing every column just for the sake of indexing every column. That's one of the reasons why we also have to be careful, depending on the environment, about sometimes, in some cases, not indexing anything, because it has such an impact on performance that it can actually be detrimental.